Hi guys, welcome to your 8.1 notes. Today we are talking about adding and subtracting polynomials. By the end of the day, you will be able to classify, add, and subtract polynomials together. Before we talk about polynomials though, let's talk about something called a monomial. A monomial comes from mono, like someone who is monotone, speaks with one tone and it never changes and it's the same one thing the whole time, and that's boring. And a monomial is one number. Nomial meaning number, mo or mon meaning one. So these are things that are one number. Now a monomial could be a real number like 18. It could be a variable like n. It could be a product of a real number and a variable like negative 16x, or variables with whole number exponents like x to the fourth power, or 3.5ab cubed is a monomial. Also, c divided by 15 is another example of a monomial. I have another term for you. A degree of a monomial is the sum of the exponents of its variables. Now, if we have a constant like 18 up here, we say the degree of that constant is 0. And then the number 0 itself has no degree. So let's look at our first example. Example 1, number A, we have two variables in play here, x to the first power, y to the first power. So we add that up, 1 plus 1 is 2. So we say that this monomial has a degree of 2. For B, there is only one variable that has a degree of 4. So we say this monomial has a degree of 4. And then finally for C, C has no variable, it's just a constant. So that has a degree of 1. Now, you can add or subtract monomials together by doing what's called combining like terms. So in example 2, number A, we have two like terms here. We have 2x cubed and 11x cubed. Now 2 plus 11 is 13. So 2x cubed plus 11x cubed is 13x cubed. In B, we have two more like terms here. We have 2a squared b to the fourth power and 7a squared times b to the fourth power. Last time I checked, 2 minus 7 is a negative 5. So this will give us negative 5a squared b to the fourth power. Now we've been talking about monomials. Remind yourself that a monomial is one number. What happens if we have multiple numbers? Well, I'm so glad you asked. If we have multiple numbers together, we call that a polynomial. Poly, in this case, means many. Like we say, a polyglot is someone who speaks many languages. And a polynomial is an expression with many numbers. So we say a polynomial is a monomial or a sum of monomials together. Now if we want to classify a polynomial, classify is just a fancy name for name. Classify just means to name a polynomial. We take two characteristics into account. We look at the polynomial's degree, and we look at how many terms it has. We look at the number of terms. So here I have a whole bunch, and let's see what we can call them. So the polynomial, our first polynomial is 6. It is just one constant, so we say it has a degree of 0. Oh, and look, I already gave it away. We call that a constant. Our second one is 5x plus 9. That has a degree of 1. We call that linear. Because if we were to graph it, it would make a line. That's where we get linear from. Our next polynomial is 4x squared plus 7x plus 3. This has a degree of 2 because our largest exponent on a variable is 2. When that happens, this is like x squared, and the term for that we call a quadratic. This makes a square. And then our next one has a degree of 3. We call that a cubic because we have x cubed. And finally, our last polynomial has a degree of 4 because 4 is the largest exponent. It's bigger than 3, it's bigger than 1. We just say it's a polynomial of the 4th degree. There's no fancy term for it, and that continues on for the rest of them. We say polynomial of 5th degree, 6th degree, a 7th degree polynomial, etc. So that's how you name a polynomial based on its degree. You can also name a polynomial based on the number of terms. This is less helpful and less common, but it will still come into play, so we'll talk about them. So to name a polynomial based on the number of terms, if it just has one term, we call it a monomial. Monomial as in mono, which is 1. If it has 2 terms, we call it a binomial. Bi, of course, means 2. For example, a bicycle has 2 wheels. Next, if it has 3 terms, we call that not a tricycle, oh my goodness, a trinomial. Again, tri meaning 3, like a tricycle has 3 wheels, a triangle has 3 sides. So if there are 3 terms in our polynomial, 1, 2, 3 terms right there, we call that a trinomial. Our next guy has 1 term. This is, again, a monomial. And our final polynomial in this chart has 1, 2, 3 terms. He is another trinomial. Now, there are such things as quadnomials if you have 4 terms, but it's less and less helpful to describe a polynomial by the number of terms, so we don't really worry about things bigger than 3. If you're really curious why trinomials have a special name, you can ask me later. So in sum, we would call our first guy, we would say he is a constant monomial. We would describe our second one as a linear binomial. And if you've caught on to the pattern, you can figure out that I'm just taking the name of the degree first and then the number of terms. Our third one is a quadratic trinomial. And then the pattern continues. So if I ask you to write a polynomial in standard form, that means to put the degrees of the monomial terms that decrease from left to right. So you start out with your big exponents, and then you slowly decrease to your small exponents to the right. So what we're going to do here is we are going to write each polynomial in standard form, and then we're going to write the name of the polynomial based on its degree and number of terms. So first I want to find which of these terms has the largest degree. Well, in that case, that's going to be my x squared has the largest degree because its exponent is the biggest. It has an exponent of 2. So that gives us 8x squared comes first. We'll follow that with our plus 2x and then end with minus 3. So to write it in standard form is 8x squared plus 2x minus 3. Now looking at this guy, he has a degree of 2, so that makes him a quadratic. And the number of terms, there are 1, 2, 3 terms here. So this is a quadratic trinomial. And exercise B, if we want to put this guy in standard form as well, we look for the highest exponent. Our highest exponent here is 3. So we're going to start out with our 4a cubed term, and then we can finish with a plus 3 minus 2. Oh, wait! We have some like terms here. We can combine these two. 3 minus 2 is a positive 1. So to write this guy in standard form, that gives us 4a cubed plus 1. Now 4a cubed is a cubic, because we've got a to the third power a cubed, and there are 2 terms in this expression, in this polynomial, so it is a binomial. Now we're going to say bye to classifying our polynomials and add them together. Now fortunately, addition works the same as you would expect it to. So what we're going to do is we are going to combine like terms. Now I have 2 kinds of terms here. I have w's, I've got a 4w, and I've got a 3w. And I've also got my constants. I've got a -5 and a +8. So I am going to combine those guys. First, what I want to do is I'm going to rewrite without parentheses. 4w minus 5 plus 3w plus 8. And then I will want to get my w's together. So according to the commutative property of addition, I can rearrange and move them closer together. That'll give me 4w plus 3w, and then I can add my -5 and my 8 together. Now 4w plus 3w, that comes out to 7w. And then -5 plus 8 is a plus 3. So this is all equal to 7w plus 3. So you can add horizontally, and it works just fine as long as you remember to combine your like terms together. My preferred method of addition, though, is actually not horizontal because I can sometimes lose track of things. I like to add vertically, and we are still going to combine like terms. I have 2a to the 4th terms here. I've only got one a cubed term here. I've got an a term, and I've got some constants. So I'm going to add those up together. Now it's very important that you line them up according to their variable exponents. Those need to match or else it won't add correctly. So let's go ahead and start out. 2 plus 3 gives us 5a to the 4th power. This is like a 0 here, so that gives us 5a cubed. -3 plus 5 is a plus 2a. And then 9 minus 20 is minus 11. So that's our final answer. Subtracting polynomials, it works just like adding polynomials. You will want to combine like terms, but first we need to take our subtraction sign and we need to distribute him to both of our terms. So if I were to rewrite that, that would come out the same as 4w minus 5 minus 3w minus 8. Now, just like our previous example, I can go ahead and rearrange these guys. That'll give me 4w minus 3w minus 5 minus 8. I'll go ahead and combine my like terms again. This gives me just one w, and then a -5 minus 8 is a minus 13. So that gives me w minus 13. Oh, shooties. Yeah, no, I'm right. I second guessed myself. And then finally, We can subtract vertically. And again, this is my preferred way. You just have to make sure that your like terms with the variables in place are lining up exactly. So we have no a cubed term here. Our a's match up and our constant terms align as well. 2 minus 3 is negative 1. I'm just going to write negative a to the 4th power. 0 minus 5 is minus 5a cubed. Negative 3 minus 5 is minus 8a. And 9 minus a negative 20 is the same thing as 9 plus 20, which is positive 29. Now that was a little fast. I'm going to go backwards and show you the step that I skipped. So it's very important to remember that you are subtracting throughout this whole process. So if you prefer to rewrite this as an addition, you can do that. You can have 2a to the 4th power plus 0 minus 3a plus 9. That's rewriting that first polynomial. Now I'm going to take the second polynomial, distributing the minus sign to each of my terms. That gives us a minus 3a to the 4th power. Taking that minus, putting it on my 5a cubed is minus 5a cubed. Taking the minus, putting it on my plus 5a gives us a minus 5a. And then finally taking my minus and putting it on my minus 20 gives us a plus 20. So this is the same thing that we would get if we added them all together. 9 plus 20 is 29. Negative 3 minus 5 is negative 8. 0 minus 5 is minus 5. And 2 minus 3 is a negative 1. That concludes our 8.1 notes today. Thank you for following with me as we classified, added, and subtracted polynomials.